Good evening, students. Today we are going to discuss paper 7, paper 7, unit paper 7, unit 14, paper 7, unit 14. Today we are going to discuss paper 7, unit 14, paper 7, unit 14. That is synthesis of pyrimidines, purines, and xanthines bases. Synthesis of pyrimidines, purines, and xanthine bases. So there is several compounds are there. That is uracil, thymine, cytosine, 5-methyl cytosine, 5-hydroxymethyl cytosine, and these are the compounds. Caffeine, theobromine, theophylline as the compounds. First, we are going to one by one. We are going to discussing. First, we are going to synthesis of pyrimidine bases. Now we are going to discuss synthesis of pyrimidine bases. So the first one is uracil. So now we are going to synthesis of uracil. That from malic acid, when CH2, CHOH, and CH2. This is a malic acid. This is malic acid. When this malic acid reacting with urea in presence of fuming H2SO4. The product is uracil. This is a uracil. The product is uracil. So from malic acid. So when this malic acid reacting with H2SO4 in presence of fuming H2SO4, it is undergo loss of water molecule and loss of carbon dioxide. It is undergo loss of water molecule like this. It is undergo loss of water molecule and loss of carbon dioxide. Loss of water molecule and loss of carbon dioxide. Then the product is formyl acetic acid. The product is formyl acetic acid. When this is a formyl acetic acid. When this formyl acetic acid, when reacting with urea, then we are obtained our uracil is the product. Okay, this is one method, synthesis of uracil from malic acid and urea. Next, we are going to synthesis. Next method is from ethyl acrylate. Second one is from ethyl acrylate. This is ethyl acrylate. When this ethyl acrylate, when reacting with urea, in presence under 210 degrees Celsius, so we produces our dihydrouracil is the product. Dihydrouracil is the product. Dihydrouracil is the product. This is a dihydrouracil. This dihydrouracil, when reacting with bromine in acetic acid, first one is, second one is when reacting the pyridine heating, pyridine upon heating, then bromination takes place at here adjacent to the carbonyl compound, then here bromine. Okay, when this compound undergo loss of HBr, then product is uracil is the product. And next one is thymine. Next compound is thymine. Thymine. Again, synthesis of this thymine from urea. Urea is reacting with the ethyl methyl acrylate. Ethyl methyl acrylate. Ethyl methyl acrylate. This is ethyl methyl acrylate. When this ethyl methyl acrylate upon heating undergo Michael addition reaction, then followed by loss of ethanol. Michael addition followed by loss of ethanol. Then the product is so that is dihydromethyl 2-methyl uracil. When this compound undergo first bromination, same in presence of acetic acid. Bromination in presence of acetic acid. And bromine. Then this compound in presence of pyridine by loss of HBr adjacent to bromine, one hydrogen is there. That hydrogen involves loss of HBr. The product is methyl NH C double bond. This is thymine. This is thymine. First one method, and second method is from thiourea. When this thiourea reacting with sodium 2-formyl propanoic acid. Sodium 2-formyl propanoic acid. When this sodium 2-formyl propanoic acid, it is involves in loss of ethanol, in presence of ethanol, loss of ethanol and sodium hydroxide, ethanol and sodium hydroxide, like, then the product is two thiothiamine. This is 2-thiothiamine. This 2-thiothiamine in presence of chloroacetic acid. Upon heating, then the product is thiamine is the product. Okay. Next one is third example for synthesis of thiamine from thiourea. When urea reacting with 2-cyanopropanoic acid, 2-cyanopropanoic acid in presence of acetic anhydride. In presence of acetic anhydride, this involves loss of water molecule. Loss of water molecule. Then the product is C double bond NH2, methyl and cyano. Okay. Now it is in presence of palladium or platinum hydroreduction and loss of ammonia. Loss of ammonia. Then the product is thiamine is the product. Then thiamine is the product. Okay. This is a method, a third method to synthesis of thiamine. And next one is cytosine. Next one is cytosine. And cytosine, the structure of cytosine is this is the cytosine. Now we are going to synthesis of this cytosine from S-ethyl thiourea. S-ethyl thiourea. From S-ethyl thiourea, then reacting with sodium formyl acetic acid. Sodium formyl acetic acid. Sodium formyl acetic acid. It is involves loss of ethanol and loss of sodium hydroxide, like previous case. So here like this, sodium hydroxide and so ethanol. Then the product is cyclation product is formation takes place. Cyclation product is formation takes place. Now it is undergo reacting with POCl3. POCl3. Now it is undergo cyclation. They convert into enol. This enol reacting with the POCl3, which is replaced by chlorine. Which is replaced by chlorine. Then this compound reacting with ammonia, loss of HCl, chlorine is substituted by NH2. Chlorine is substituted by NH2. When it is reacting with HBr, sulfur is replaced by oxygen. Cytosine is the product. The formation takes place. Next one is 5-methyl cytosine. 5-methyl cytosine. This is the structure of 5-methyl cytosine. This is a 5-methyl cytosine. Okay, now we are going to synthesis of this 5-methyl cytosine from thiamine. Thiamine is a starting material. This is a thiamine. When this thiamine reacting P2S5, that oxygen, keto-oxygen is replaced by sulfur. Keto-oxygens are replaced by sulfurs. In this compound reacting with ammonia, so this ketone is replaced by NH2. And reacting with HCl or HBr, sulfur is replaced by oxygen. Sulfur is replaced by oxygen. There is 5-methyl cytosine. 5-methyl cytosine is the product. Next example is next compound is 5-hydroxymethyl cytosine. 5-hydroxymethyl cytosine. 5-hydroxymethyl cytosine. 5-hydroxymethyl cytosine. That is, the structure is this is 5-hydroxymethyl cytosine. So we are going to synthesize this 5-hydroxymethyl cytosine from thiourea. And thiourea. In this thiourea reacting with ethyl methoxy methylene cyanoacetate. This ethyl methoxy methylene thiocyanate in presence of sodium methoxide undergo cyclic ring formation takes place. NH2 and COOET. Okay, now this compound when reacting with methylated, sulfur undergo methylation takes place. Sulfur undergo methylation takes place. When this compound reacting with lithium aluminum hydrate, and this compound reacting with methyl aluminum hydrate, then the product is NH2 S methyl N, and here this ethox ester is converted to methylene alcohol, and when reacting with HBr, the sulfur is replaced by oxygen. The hydroxy is converted to ketone. This is 5-hydroxymethylene cytosine is the product. Next, we are going to synthesis of purine bases. These are the pyrimidine bases. Next, we are going to synthesis of purine bases. Next, we are going to synthesis of purine bases. Next, we are going to synthesis of purine bases. That is adenine, guanine is the pyridine basis. We are going to synthesis from adenine. This adenine is the structure of adenine. Hydrogen here, NH2, here chlorine. This is adenine. So next synthesis of adenine from uracil, uric acid, from uric acid, from uric acid, is uric acid. When uric acid reacting with POCl3, the ketones are converted into carbonyl compounds. Ketones are converted into carbonyl carbons. Ketones are converted carbonyl compounds. This is 268 trichloropurin. This is 268 trichloropurin. When this 268 trichloropurin, when reacting with aqueous ammonia, 1 mole of aqueous ammonia, 1 mole of aqueous ammonia, this chlorine is replaced by methyl group. The chlorine is replaced by methyl group. Here chlorine NH. When it is reacting with HI, chlorines are replaced by hydrogens. Then the product is adenine is a product. So these are the HS hydrogens. The product is adenine is the product. The product is adenine. Next one is we are going to synthesis of guanine. Next one is this is the first method to synthesis of adenine. Second method of synthesis of adenine is from formamide. Formamide. When this formamide reacting with phenyl melanonitrile. Phenyl melanonitrile. When this phenyl melanonitrile in presence of sodium ethoxide and ethanol solvent, the product is NH2. Here NH2, NH2, N2 phenyl. And this compound reacting with raney nickel hydrogen, the bond is breaking here. Then the product is NH2 and here NH2, NH2. These two compounds, when the compound reacting with this compound reacting with thioesteric acid, which involves loss of H2S. NH2. In this compound in presence of water, then the product is adenine. Then the product is adenine. So next one is guanine. Next one is guanine. And this guanine is, we know already, synthesis of guanine is from guanidine. Reacting with cyanoacetic acetic ester, cyanoacetic ester, cyanoacetic ester in presence of sodium ethoxide, NH2, double bond N, NH, keto, NH2. In this compound undergo reacting with HNO2, HNO2. First one is nitrosylation takes place. In this nitroso compound reacting with ammonium hydroxide, that nitroso is converted to amine. NH2. And this compound are reacting with sodium formate in presence of formic acid upon heating, then forms guanine is the product. Then guanine is the product. Okay, this is a synthesis of purine bases. Next one is xanthine bases. Next one is synthesis of xanthine bases. Next one is synthesis of xanthine bases. First one is caffeine. Caffeine. First one is caffeine. Caffeine. So first method is Trobe method. So in this instance of Trobe method, this is a caffeine. The structure of caffeine is a caffeine structure, methyl, methyl, and methyl. Now synthesis of caffeine in Trobe method, that is N-dimethyl urea, N-dimethyl urea, N-dimethyl urea. When this N-dimethyl urea reacting with ethyl cyanoacetate, in presence of sodamide, then the product undergoes cyclation takes place. Here methyl, keto, and keto, NH2. So when this compound reacting with HNO2, so nitrosylation takes place at adjacent of ketone. When this compound reacting with zinc acetic acid, H2SO4, zinc sulfuric acid, that nitroso is converted into amine. Nitroso is converted into amine. When this compound reacting with formic acid, loss of water molecule and H2O, then the theophylline is the product. here hydrogen. These are the methyls. Okay. When this theophylline reacting with methyl iodide in presence of base, this hydrogen is replaced by methyl group. This is the caffeine. Next, we are going to synthesis of theobromine. Theobromine. This is an important method. Okay, actually two methods are there: Fisher and Troop method. But Troop methods are very important. They're asking every time Troop method for xanthine bases. Theobromine. The structure of theobromine is this is a theobromine. Now we are going to synthesize theobromine in Troop method. For here we are taking only N-methyl urea. This N-methyl urea reacting with ethyl cyanoacetate. Ethyl cyanoacetate in presence of POCl3 and NaOH. A ring formation takes place. Hydrogen here methyl, here double bond O, and double bond and methyl. When this compound first when it's reacting HNO2 and this position is undergone nitrosation, and second one is when reacting with zinc in sulfuric acid, that nitroso is reducing to amine. Amine. Okay. Same when this compound reacting with formic acid undergo loss of H2 and H2, undergo loss of H2O and H2, NH, double bond O, N methyl, C double bond, NH, and keto. When this compound reacting with base sodium methyl iodine base, this five-membered nitrogen and hydrogen undergo methylation takes place. This is the theobromine is the product. So last one is theophylline. Last complex compound is theophylline. Last compound is theophylline. The structure of theophylline is this is a theophylline. Okay, we are going to synthesize theophylline from Troop method. That is when reacting with urea in presence of methylamine, 2 moles of methylamine, then the product is NN dimethyl urea. When this NN dimethyl urea when reacting with ethyl cyanoacetate, a ring formation takes place. NH2. And this compound reacting with HNO2, and this position undergo nitroso, and reacting with the zinc in sulfuric acid, that nitroso is converted to amine. That nitroso is converted to amine. And this compound, when reacting with formic acid, loss of water molecule in H2, then forms theophylline is the product. Then forms theophylline is the product. Okay, these are theophylline. So these are the compounds we are discussing in pyrimidine basis, purine basis, and xanthine basis. So compulsory one question we are expected in your exam from these three bases: pyridine basis, purine basis, and xanthine basis. Okay, so in xanthine basis they ask true method for synthesis of any xanthine base. Okay, theophylline, theobromine, caffeine, and so these three bases are very important for in your exam. One question is must ensure in your question paper. Please practice and thoroughly. Okay. Thank you.
Sir, I have a small doubt.
Ah,
You gave the structure of theobromine, right, earlier?
yes.
Um, the doubt may be a little silly, but
Hmm.
there is no bromine in it. But why is the name given theobromine to that compound?
Okay. Actually, every time students asking this question, but actually we don't know that actually the scientists discovered this compound. So I think we are the naming of the scientist is the name given by the compound. Actually we don't know actually exact reason for this theobromine. Okay,
Okay, okay,
actually
sir.
every time they're asking strange like questions, but actually theobromine is said, but there is no bromine asking like that. Okay,
Okay, okay,
మైసూర్
sir.
పాక్ లో మైసూర్ లేనట్టు సో ఇలా థియోబ్రోమిన్ లో బ్రోమిన్ ఉండదు. ఓకే,
Okay, sir.
థ్యాంక్ యూ. But listen me, just you concentrate on the structures. In caffeine, all nitrogens are substituted by methyls. Okay. In case of theobromine, two adjacent rings, 5-membered ring and 6-membered ring, methyl groups are nitrogens are substituted by methyl. In case of theophylline, so in 6-membered ring, 2 nitrogens are substituted by methyls. Okay, just to concentrate on the structures. Otherwise, you get
Okay,
confusion. Okay,
okay, sir. Thank you.
thank you, thank you.
So, can we get this notes in the group? Is it possible?
Definitely, I will send you. Okay. Hmm?
Okay, sir. Thank you, sir. Thank you very much.